gentlemen. I will try to present a different paper because I am an electrician. I'm not mechanical engineering, I am not building services engineering, I'm an electrician. But I think that this paper will be related with your field of expertise also. First of all, I'm not from Timișoara. I am from Cluj-Napoca, from Transylvania, from Romania, yes. But it was a little fault in your program, but no problem, no offense for me. Thank you. Presentation. How say it? You have a mouse also. Thank you. Speaking about the title of my paper, and what Professor Rams said in the beginning, I had also to adapt myself, because when I graduated, electromagnetic compatibility was not born. I was an engineer, and no one knew about electromagnetic compatibility. It's a new concept, 20 years old, yes. And power quality was known only about the results of Budeanu, 1932, and Friese, 1933, about harmonics. It was all known at that time. So, I have a motto here for my paper, and the motto says, think EMC. That means that we must always think about compatibility. You know, compatibility is very important. Compatibility is important in a couple. It's important in a family. It's important in a community. And it's also important in smart grids, in electric grids, and so on. So, here I have a definition of electromagnetic compatibility, but I'll be short, I don't read it. And my feeling is that power quality and electromagnetic compatibility are not dichotomous. They are tightly related, because this is a chain relation, reaction between power quality and electromagnetic compatibility. Power quality means low frequency phenomenon. Electromagnetic compatibility means high frequency phenomenon, but they are related because power quality issues turn in electromagnetic compatibility issues and vice versa. And I'll demonstrate that. My paper will focus on two different stories. Yes. The first one is a story about an air conditioning, air handling unit, and I received a phone call from one of my former students who works in Norway, and he told me, Professor, I have a big problem because I installed in a neighborhood here in our town a lot of air handling units, and they are not working properly. And now, here, at that level, begins the problem of the engineer. When everything is okay, but it doesn't function, it doesn't operate properly. So, I taught him a little trick, rule of thumb, because there are also in every field of expertise, there are some tricks. And he managed to solve the problem. But we made a little further research on this topic. Everybody knows what air handling unit represents, yes, because you are expert in this field, not like me. But as I want to say, that we focused on the input stage of the drive circuit, because in this input stage there is a any filter here, yes, but there is also a rectifier, yes, and using clean power source, we managed to observe the voltage, which is very correct, a sine wave shape, and the current is highly distorted. The FFT, the fast Fourier transform chart of the current, put in evidence a lot of harmonics. Harmonics which are overheating the fans, the motor of the fans, which are determining countercouples, which are determining oscillations. Finally, which are making the customer to pay an energy for harmonics which is not efficient, which are harmful for the equipment. Here we have the harmonics, yes, the harmonic content. We made the analysis for one motor of the two fans and for the whole unit. Yes? For one motor, there were no problems. There are here some regions or some values with orange and with green, which are close to the standardized limit. But one motor was in the standardized limit. But when we tested the whole air handling unit, we had two motors in parallel connected. And it was not the same thing. You can see here with red the values and the harmonic orders which were overcome and which was exceeding the limits of the standards. It was a problem here. So, in order to make a relationship between power quality and electromagnetic compatibility, we also checked the air handling unit, yes, for electromagnetic compatibility for conducted emissions. Yes? And you can see here the results. Exceeding, yes, the limits with red, you can see the maximum limits are exceeded. So, the air handling unit, which was on the market, had a few issues. We had to fix them. So, in the final part of the paper, I'll show you how we have fixed this problem. The second story. A friend of mine came and said that in the neighborhood in our town, the heating centers, gas heating centers, didn't function properly. He didn't know why. It was the countryside, yes, but in the neighborhood of that village was installed a radio broadcasting station, AM, amplitude modulated radio broadcasting station, and that waves, radio waves, were induced in the overhead lines, yes, low voltage overhead lines, and they created problems in the electric grid in the village. And all the heating centers in the houses didn't function properly. Yes. So we went there, yes, and we measured the grid, yeah, from the point of view of radio frequency emissions. You can see here that the values exceeded the limit from the standard. It was also a problem. So we had to fix these both problems. The solution was an EMI filter, electromagnetic interference filter. Yes? So we had to design, I had to design such a filter, or two such filters, solving the problems. Yes? So I don't enter in details. I am not entering in details because all of you are hungry now, even me. So this is the schematics of such a filter. Yes? And when someone wants to design such a filter, he must think in EMC. He must think in at the hidden schematics of every element composing this filter. The ferrites, the capacitors, the resistors, and everything from here. No one is ideal. Everyone has some issues. So, the ferrite, yes, the magnetic material, you can see, is effective depending on the material. The ferromagnetic materials are effective until 1 megahertz. You can see here. Yes? Though from zinc and mangan, they are effective to 10 until 100 megahertz. And those from nickel and zinc, they are effective until 1 gigahertz. On the other side, every element of circuit is not ideal. The ideal perhaps is in heaven, but not in the earth. Yes? So, the resistors have an equivalent schematics here, and here another one, two equivalent schematics. We have simulated it with MATLAB, and you can see here that we have this diagram of the magnitude and of the phase versus the frequency. They are not equal in the whole range of frequency. The capacitors, until the self-resonant frequency, have a capacitive behavior. Above this frequency, they turn in inductive behavior. So, the inductors also begin to be resistive, after that inductive, and finally they turn into capacitive behavior. Okay. So, I'll finish. We designed the two filters, and the results, the characteristics of the filter was presented in this slide. You have seen that the filter made an attenuation of almost 40 decibels. After that, we have retrofitted the filters at the entering of the two equipment, and we measured the results. The final spectrum for the echo, which was in of the gas heating central, which also was in the limit. Conclusions are all yours. Thank you very much.
Thank you, Mr. Buzdugan. It was very complicated, but I hope it will show us a new view to the mechanical equipment we know about. So thank you very much.
Sorry.
There is a small question.
So sorry. So the conclusion, your conclusion was that my paper was very complicated. Thank you.
No. Important question. The Marriott Hotel in Bucharest, the 5-star hotel, the best in Bucharest, is situated exactly near the Ministerium of National Defense. The Ministerium of National Defense is filled up with security systems and GSM connections, radio, and so on. I want to tell you that we felt such phenomena in the Marriott HVAC systems, governed by Siemens BMS,
yes.
Fantastic, but nevertheless we have a lot of disturbances in our HVAC system in the Marriott.
That's normal.
Good, it's normal?
Yes, that's normal, but moment please. Siemens have to solve this problem. They have to sell to Marriott, to the hotel, the filtering systems, proper filtering systems to solve these issues.
You can recommend Mr. Buzdugan to Siemens.
No, I know that. Thank you.
Thank you very much. Just a short question, please, because we have a problem with
I
timing.
would like to have lunch.
Has frequency control impact on that?
I'm with that.
Frequency control
What?
impact on that.
If you have a frequency variable system or frequency control on your HVAC unit.
Yes, there are.
I suggest...
Sorry, one moment please. Yes? The motors were brushless DC motors, and they are power electronic controlled.
I suggest to continue this during the lunch and to give the opportunity to the other colleagues